Where did we stop last class? Yes. Coming. We completed chapter 4. Anybody has any doubt? Huh? Are you doing homeworks? No. Okay, let's start with the next chapter then. So refraction of light. Oh, I do again. Refraction prevalence. So you're already familiar with length. Was it introduced in the lower topics? Okay, so what is length? First of all, just like rectangular glass slab or a prism, it is also a transparent medium. But now it doesn't have a plane surface, it has a spherical surface. Right? What is lens? It is a transparent medium. Bound by spherical surface. But surfaces such that at least one of the surfaces is spherical. Very. Okay, this is what is. So let's see the transparent medium or two surfaces. Such that at least one of the surfaces is spherical. So with this in mind, we can have lenses like this. Yes. So these are three different types of surfaces. So if you look at, let's say you have two dish, okay, and you join them like this. So this will be circular. This is spherical, right? And this is off. When you see it from the edge, it will appear like this. I think so. Is the attendance sheet around? Then it must be. Yeah, it is there. Okay. So when both the surfaces are spherical, then it is called biconvex. Biconvex or equiconvex. Or equiconvex. Biconvex, right? This is planoconvex. Yes. And this is concavo convex. So this type of a lens is convex. So what is convex? It is thinner at the edges and thicker in the middle. Okay. Thinner at edges and thicker. No. Okay. So depending upon the type of surfaces, the lens gets its name. Then the other type of lens we have is concave lens. What is concave lens? It is thicker and thinner in the middle. Okay. So with this we have so therefore this will be called biconcave. This is called plano-concave, and this would be called as this is called convexo-concave. Okay. So, what are the defining characteristics? If you look at the edges are thicker here. There might be some confusion in this and this diagram. But if you follow this description, convex has to be thinner at the edges and thicker in the middle. Okay, how it gets its name? From the kind of surfaces that are bounding the medium. So this is plano-concave because one plane surface and one concave. This is one convex and one concave. So convex and concave. So primarily it is concave because it is thinner in the middle and thicker at the edges. This is how it gets its name. But you have to study about these two, this and this. We're not going to study about rest. Okay. So basically, whenever I say convex lens and concave lens, it means biconvex and biconcave with equal curvature on both sides. So it is symmetric. Okay. So in the clear the passage, keep the bags off. Take this attendance sheet. So we got two lenses and we'll be learning about the image formation of these lenses, followed by the sign conventions, add some dividers. Okay. Now we'll study about what is called as lens action. Right? Let's go deeper in learning about how the refraction of light takes place by lens. So if you pick up a convex lens, and look at its geometry, right? Okay. If you look at its geometry, you can divide it like this. Yes. So you can see that it is nothing but combination of some prisms stacked over each other and a rectangular glass slab in the middle. You can imagine like that. And you're familiar with how the ray behaves once it is refracted by a prism or a rectangular glass slab. Okay. So let us understand the lens action. So let us say this is your principal axis. And this is the center of the lens, which is named as optical center. In mirror, we call the center of the mirror as pole. But here the center of the lens is called optical center. So this is the principal axis as usual. Now let's see what happens to the rays which are incident on the lens. So what is the nature of refraction when the light passes through prism? It always, when it enters, it bends towards the base. Always the ray bends towards the base of the prism. So we'll enter here. First refraction at this surface bends here, right? It bends towards the normal. Then from this normal, it goes away. It bends again. Okay, this is what happens. Bends twice. So here also, this could be another prism with the head chopped off. Happened refraction at the first surface. Then the second surface again. So two bendings here as well, right? Now this is like incident normal on the rectangular glass slab. So it is passing straight. Okay. Even if it was passing at an angle, we'll see that later. And likewise, you can think of rays which are below the principal axis. It will also suffer refraction twice, 2 times bending. So this is exactly, you're aware as to how refraction takes place through a prism. Right? So nothing new. Now it's the application of the knowledge learned in case of lens. Okay, 2 times bending, and that's how it actually meets at a point, which will be called as focus, as we'll see later. So this is the lens action. So it can be thought of as the stack of prisms kept one above the other, and in the middle it is a rectangular glass slab. And you're already familiar about the behavior. Please settle down here. Settle down here. Keep the his bag also here only. First you enter in. So this is what is lens action in short. But when we draw the ray diagram, right? So draw it like this. We don't show the bending twice. Okay? When we draw the ray diagram, we take the ray till the middle of the lens. Right? Fully aware that if the ray is parallel, it will pass through focus of the lens. Okay? So this is how the ray diagram will be drawn. So you don't have to worry about too many bendings at every surface. Now, once the lens action is understood, while drawing the ray diagram, you'll stress the ray till the middle of the lens and then take it out. Okay? So bending at both the surface need not be shown. Is that clear? So this is what we'll follow. So note down till here. This is what we know. Just minimize. Minimize, not close. Which either left. Aditya का है. और hope you are drawing lenses too bad, looking like a diamond. ऐसा नहीं होना चाहिए. The surface should be curved. Anybody yet to sign the attendance sheet? I'll erase the left side. You can see from the video or borrow from somebody. So far we have seen what happens to the rays which are parallel. Now we'll see what happens to the rays which are slant. Okay. So again if we draw it multiple parts. So the middle part is like a rectangular glass slab. Okay. What if the rays are coming like this? Right? So again, since this is a prism, it will bend twice, goes down. Now this is entering a denser medium. So it will suffer, and then this also goes down. There will be no deviation, right? This will be parallel. Okay. And any ray coming at the bottom, so it will bend towards the prism base. Again, bend like this. So when the ray is not parallel, right, you will see that it will be in the focal plane. So it will not be at the focus, somewhere in the focal plane. What is focus? What is radius of curvature? You're familiar for mirror. Similar thing for lens, but it has got now two focuses, a pair of focuses, because it has two curved surfaces. We'll see that in a while. But is the lens action clear? So you see the ray which is coming straight, it is not deviated, right? So it bends like a rectangular glass prism. When it enters the denser medium, slightly bends, then laterally shifted, right? But in reality, the lenses that we use in practical life, they are very, very thin. Okay. And you know that lateral shift is a function of thickness of the lens. So if the lens is thin, this lateral shift will be almost not there. So any ray which is passing through the optical center will pass straight, henceforth. It will be shown undeviated, right? For example, so everything is related to the thickness of the lens. All the lenses that we use in real life, like mobile, okay, all these camera lenses or the eye lens, these are very thin in real life, okay. So in real life, it won't be this thick, except the magnifying glass, of course, which you're familiar, right? But in all the practical optical devices, the lenses are very thin. So, in any way, since it is rectangular glass slab, there is no deviation. So now will henceforth will show straight, not bending inside the lens. Is that clear? And for other rays, anyway, it will, if this is focus, so other rays will meet here. So the clue is whenever you're drawing the ray diagram, you have to take few rays above the principal axis and few below, or few above the optical center, few below. Okay, mostly one is enough. One through the optical center, one above optical center, one below, for the symmetry of the ray diagram. Is that clear? So this is all about how we draw ray diagrams for lenses. For convex lens we have seen. Now I'll tell you how to draw ray diagram for concave lens. So let us see lens action for concave lens. We can think of concave lens again as a series of prisms stacked above each other. Right? This. So this also can be thought of as a stack of prisms, right? Head is short, that's okay. Refraction, we are looking at refraction in the middle region of the prism. So what happens now? Let's take two rays. Where will it bend? Towards the base. Where is the base of the prism? Upward. And then again towards the base. Okay. Likewise, one here, one down. Okay. Now in this case, the focus, these rays are diverging. So always the diverged rays are extended backwards. So it will meet somewhere. So the nature of image formed is different. Here the image will be real and inverted in case of concave lens or convex lens, because the rays are actually meeting. So real images will be formed like this. Whereas in case of concave lens, the rays are extended backward and this is focus, right? And this image will be virtual image. Hope the difference between real and virtual image is clear to you. Virtual images cannot be obtained on screen, right? And it forms at a place where the refracted ray appears to meet when extended backwards. All right. So this is what is virtual image, and virtual image is always upright. Real is inverted. Virtual image is upright. Okay. Likewise, if you take more rays, it will undergo the same fate like these two rays. So is the lens action clear? But while drawing the ray diagram, you won't show the bending twice. Show the bending twice. You will just you take the rays to the middle of the lens and then show it once. Bending is shown only once on the middle of the lens. Now that we know the lens action. So ray diagrams will be drawn like this. Okay. Right. So right now I have shown only one focus for simple understanding. Now we'll get into the details of what are the two focuses every lens has and why it has got two focuses. So till here, are you clear? How many rays you will consider for ray diagram? At least two. You have one above, one below. At least two for image formation. And what is a real image? When the rays actually meet after refraction. So they are meeting after refraction. Real image is formed. And when after refraction, right, the rays are diverging, wherever they meet on extending backwards, that is the place where the virtual image will be. Okay. So far, these two concepts will be entered in your head. Everywhere. The middle of the lens is optical center. Okay. Can I erase this part? Let us learn about construction of lens. And terms associated with. Okay. Now let us see how the convex lens is made. Convex lens is made out of two identical solid spheres. Imagine this is a perfect sphere. Okay. Right? So this is a sphere, it is not looking like it. Orbiters. Now, so it has got these two spheres are overlapping. So the lens is carved out of these two. These are two solid spheres. So it has two centers of curvature, C1 and C2. Right? And this is the center of the lens, which we'll call optical center. So the line that passes through both the centers of curvature is principal axis. Okay. And this distance is the radius of curvature R1, and there are two radius of curvature. Okay. And you know that what is the focal point? Half of radius of curvature, isn't it? So you will have two focuses here, F1 and F2. Okay. So what is focus? It is half of radius of curvature. So in case of mirror, you had only one focus because there was only one surface, right? But in case of lens, since you have two curved surfaces, so there are two radiuses. So two radius of curvatures, and therefore two focuses, right? So this is why the lens will have two focuses. Sometimes, now this is f1 and this distance is double, so it is also written as 2f1. Okay, and this will be written as 2f2. Now in the book, right, you will see this is the first surface. This is surface number 1. This is surface number 2. So for the first surface, sometimes they will call this C1. Okay, we'll come to F later on. For the first surface, it is C1, and for the second surface, it will be called as C2. But don't worry about it. Okay, all the nomenclature. If this is the first surface, this is C1, and this is the second surface, so this is center of the second surface. Just the nomenclature. Don't worry about it. It's absolutely symmetric because we are only going to study about symmetric lens with both curvature equal. Is that clear? Okay. So therefore, this then will be R2 and this will be R1. So it does not matter really. R2 and R1. Okay. Having understood this, now let us define the terms in detail. This is the basic construction of lens. Whenever you draw the ray diagram, this is the starting point. Draw the lens and draw this horizontal line called principal axis. Okay. Then mark 2 points on the left side, 2 points on the right side. Okay. For the convex lens, now this is called the first principal focus. What is it called? So here I taught you C1 here, so accordingly F1 should be here, right? But forget it, right? It doesn't matter really. Now this is the real definition. This is the first principal focus, and this is the second principal focus. F1 and F2 are first and second principal focus of convex lens. Okay. What is O? O is the optical center. O is the optical center. Now this is F1, so this will be called as 2F1, 2 times F1, this distance. And this will be called as 2 times F2. We will not be calling it as C2 and C1. I don't know, in ICSE only they follow this nomenclature. In CBSE, it is both FFCC, no confusion. Here they have named it. First principal focus, second principal focus. Now, how do they define first principal focus? It is the point, okay, from where, when the ray emerges, okay, right? After refraction, it will become parallel. What is the definition of principal focus? the point from where, when the light ray emerges, becomes parallel after refraction. Right? So this will be defined as first focus for convex lens. That's it. So once you know what is first, everything else is the other. Is that clear? Convex lens, F1 is on the left. Then, so first you note down till here. Then I'll explain more concave lens. That pencil, okay. Yes. Awesome. So anybody has any question till here? Yes. Symmetric center of the lens. And center of this distance will be which is radius of curvature, the distance, and half of it represents focus. Focal length. Small f is focal length. R is, you can have, it is same, so I'm not writing R1 R2. It is radius of curvature on either side. So there is a difference between center of curvature and radius of curvature. Center of curvature is a point. Just like principal focus F1 and F2 are the point on the principal axis. Whereas R is the distance or length. Same as this is the focal length. Okay, so these are the parameters which are required to define a lens. The lens would have a focal length, we have a radius of curvature, and we have focus and center of curvature. These are the points of the principal axis. What is principal axis? The line that goes through all these points is the principal axis. Then any term undefined. There would be one more term aperture. The idea of the diameter of the lens. This. So aperture is the maximum surface over which the incident ray will expose the lens. Okay. Just like what is the aperture of eye? The area, what's the aperture of eye? It's very even. The aperture is how much light is allowed to enter the eye? Yes, you think is the level. It's the battery level. So you step over and right eye. People will increase or decrease the diameter of the just to be able to handle it. That's yes or right. To brightness when it is already over because it is focus. Okay, only the required amount of light is allowed to reach the eye first. Because of the automated circuit projection balances. What is principal axis? This is principal axis. Not here. This. ये क्या लिख रहा था मैं? This is radius of curvature. Okay. Everybody done with the points. This is the normal for nuclear drawings. Got used to it. The artist is not. Commercial artist. Is it looking different kind of art? It's totally geometric. With the lines, circles, triangles. Most of the artists at a thought level, still is made with circles, lines, and triangles. Okay, shall we go further? Raise your hands still to a drawing. Raise your hands. Okay, we can go further. Whatever we learned for convex lens, we do the same thing for concave. So what will be for concave lens? Again, it will be constructed out of two solid sphere. Okay, these are the two spheres, but it is one part, right? So obviously there will be mold in which the liquid would be super cool to actually manufacture this. But why it has two radius of curvature is because of this. So this is O, right? Now what is this? This is surface 1. So this becomes C1. First surface C1. This becomes C2. So this should give you the clue that the principal focuses for concave lens will be different. Okay, you get the clue? So now you have different principal focuses. What about concave lens? What did I tell you? What is principal focus? It is the point on the principal axis from where, when the light source, okay, when hits the lens, it becomes parallel. So just like the convex lens, it would have two principal focuses. But now let us see, where are these 4 points? Again, I'm repeating. First step is draw the lens, draw the horizontal line, mark 5 dots, one in the middle of the lens, and don't label it till you complete your ray diagram. Because if you label it, and when you draw the ray diagram, it will pass through the written later. So then you'll have to, erase it and write it again. So don't do that. Just mark the dot. And these dots are symmetric. Like these distances are equal. If this is 5 centimeter, this would be 2.5 and 2.5. Likewise, 2.5 plus 2.5. Okay, symmetry. Now in this case, the ray has to become parallel. So for that, it has to be incident along the focus. Right? The refraction will bend towards the base. You know? So it bends towards the base and becomes parallel. So the incident ray became parallel when it was incident toward the focus. Now the first principal focus for concave lens will be on this side. Okay. Okay, so you have to know where is the first principal focus. For convex lens, it is on the left side, and for concave lens, it is on the right side. How do we define first principal focus? The ray either emerging from that point or appearing to be emerging from there has to become parallel after refract. After refract. Come to the diagram first. Convex lens में कैसे हुआ? Convex lens में क्या हुआ था? The rays were emerging from here and it became parallel. So we defined this as F1 for convex. In case of concave lens, or it is also called diverging lens, right? So you can write this name for convex as converging and concave as diverging. When you wrote convex lens, write that as converging and diverging. So that's helps to remember the lens and its making. Okay. Concave lens is also called concave or diverging. And convex is also called converging. Right now. So are we good till here? Now what we're going to do is image coordinate by like this. Can somebody explain how this ray became parallel? this case. How the ray are becoming parallel. Exactly. If you reverse it, it will diverge. So symmetry. Okay. Sometimes confusion may arise. ऐसा कैसे हो गया? Just think of it like this. This you are comfortable. For convex, what we did, if a parallel ray is coming, it is converging. And when we reverse it, to define the principal focus, the ray emanating from focus also will become parallel. Okay? So that way it will help you remember it. All right. So I think we are good to learn about the image formation by lenses. So far we know what is focal length. This length, distance of the principal focus from the optical length. This is focal length. Okay. What is the radius of curvature? That is it. What is the relation between focal length and radius of curvature? F is always R by 2. Focal length is always half the radius of curvature. Right. Now let us learn image formation by convex platform. Okay, so there are 7 ray diagrams. Out of 7, 2 are common, so actually 6 object positions. Okay, so let us start for first case. Image formation by convex lens when the object is at infinity. So infinity is like very far away, like sun. Sun is some object which can be regarded as at infinity. So how the image will be formed by the convex lens when the object is at infinity? So the first step, lens, the horizontal line, which is principal axis, and 5 dots. Okay, 5 dots with start with the center dot and 2 dots equidistant from O on either side. Now, when the object is at infinity, like when you're looking at sun, so how are you looking at sun? Like this or like this? Straight, right? When the object is very far away, all the rays coming to you from the object are parallel. Okay? So you will have only parallel rays. Whenever the object is at infinity, you will only have parallel rays and parallel to principal axis. So we know that when the ray is parallel, it will pass through focus. Okay. Now you can label the diagram. This is O F1 and 2F1. F2 and 2F2. So what is the where is the image position? So for every object position, you have to mark the image position, which is F2. Nature of image. Nature of image is the rays are physically meeting each other. It has to be real. And when the image is real, it is always inverted. And it will be highly diminished or diminished to a point. Okay, what is the size? Three things about the image you have to mention. Size of image. What are the three characteristics of image? Image position, nature of image, and size of image. So this is highly diminished. Or point sized. So whenever the object is at infinity, this is what happens to the image. That's why values obtain the image of sun, right? Like these are magnified fast. And you focus it on a paper. The entire sun converts it to a point. That's why the paper starts burning. Okay, that's how you get burn. Right? Use the lens and burn it glass. Have you done this experiment? Right? The optic image also. On a paper, people burn it. So a childhood, we used to focus on friends and so it's unaware. Suddenly something happens. So won't do that. Like we are again because it can burn. Both are not careful. No penny. चैलेंज कर रहे हैं बदमाशी दिखाता हूँ okay. अच्छा अभी तो एक चीज और देखोगे जो familiar with image formation by concave mirror जैसा concave mirror में था exactly convex lens में exactly what a single change whatever was the what ये for your understanding it is good but don't write this in the paper. So for correlation purpose, whatever was the image position, if the center of image is right of the box, concave exactly same as the convex lens. Let's discuss the next one. Far away object. Let us see the image formation of a far away object by convex lens. Okay, again I have dot 5 dots marked here. When the object is far away, the rays are parallel to each other, but they are not parallel to principal axis. Okay, this is the difference. So first ray, the trick is you draw the first ray from the passing through the optical side. Okay, this is the first ray. You have to show the direction for the incident ray and the refracted ray, right? Two direction per ray. Take one ray above and one ray below. It should be parallel. So now what will happen? This is pass through focus, so it should become. And where it will meet now, it will meet in the focal plane. This is the clue. Draw the focal plane, a perpendicular passing through the focus. And then join this point. So you can actually know where I have to draw at which point, exactly where the image will be formed. It is forming in the focal plane, right? Not at the focus, focal plane. So it is on principal axis, it is focus only, right? This is F1, this is 2F. Understood? So whenever you have a faraway object, again, the image characteristics will be same, exactly same. There's no difference. Image position. At a point in focal plane. So again, so what is the image position? F2 only. Because you have to measure the distance from the optical center. Again, the distance will get same. What is the distance? Focal length. F. Here also, what is the distance? F. So the distance remains same. But the point is now on the focal plane, not at focus. This is the only difference. What about the size? It is still highly diminished. Because if you look at the object size, you don't know what is the size of object. It's very big object. What is the nature of image? What is the nature of image? Huh? Yes. Nature of image is real and inverted. Why real and inverted? Why real and inverted? Why real and inverted? The rays here. Actually, physically intersecting. Okay? That's why it is real and inverted. Right? Now, what is the size? What is the size of image? Whenever you give the size of image, it is in comparison to the size of object. So again, you don't know where is the object. So it is so big, right? As compared to object, you can see it is highly diminished. Okay, so it is highly diminished. So case 1 and case 2 are actually similar in terms of the image position, the nature, and the size of it. Exactly same. Direction has to be or incident and refracted above. The ray diagrams. Draw. Try to draw practice. Now, this is the kind of practice. Plus, forward direction. Everyone is forwarding direction. Complete diagram. Direction and labeling has to be perfect. It has to be continuous, not be broken. Right. For everything, let's go draw everything. This is the actual topic. Image forward to conversion. So, for exactly the way I'm talking. Slightly big, yeah, but छोटा छोटा क्यों बना रहा हूँ? Everywhere, like, see, is going to area. Discussing right now this popular तो मैं कुछ समझाने के लिए बना रहा हूँ आगे इसी वाले. Okay, I missed one point. How many rays to be considered for drawing the ray diagram? There are basically three rays, right? Ray parallel to principal axis, it always passes through focus. Ray which is incident along optical center will go undeviated. And any ray incident along focus will become parallel. Okay, only three. Out of these three, any two. So mostly all the ray diagrams have a ray parallel to principal axis and a ray passing through optical center. With these two rays will complete all the diagrams. Okay, so you'll become experienced. So how many rays will be considered over the question in here? Once upon this one. Yes, we see. तीन खाली infinity वाले में जरूरत है, बाकी सब में दो ही चाहिए. Okay, only for this diagram three rays. All other you can do with two or three. Everybody has drawn these two. Show me everyone. कोई काम तो दोनों रे निकाल दिए डायरेक्शन आप कर देना है तो ठीक है ऑप्टिकल साइड पर सब जगह है लेबलिंग एंड डायरेक्शन. Okay, the real rays, only the real rays will be solid. Okay, this is extended. That's to be dotted. Okay, it should be clearly dotted. You don't go above. Okay. And you have to draw the direction. There also make this way, right? So before and after, both directions are required. This is a refracted ray, this is incident ray. Before and after. So in the ray diagram, N4 don't wait. अभी ये अलग से करेंगे. वहाँ पे लेंस के बीच में ऑप्टिकल फैक्टर आएगा. Direction has to be before and after the whole. There also. ये अभी दोनों में ये red आएगा. देख हो गया red. देखिए मैं. देख कर लिया. हाँ दिखाओ. बनाया कि नहीं? ये वाला स्मॉल है कैपिटल नहीं है. ये सिर्फ एक्सप्लेन करने के लिए किया है मैंने. रे डायग्राम में मत बनाना. बताता हूँ. जो कैपिटल एफ है, कैपिटल एफ, इट इज अ पॉइंट. सम ऑफ योर राइटिंग दिस आल्सो इज कैपिटल एफ. प्रत्युष, some of your writing this also is capital F. This is not capital F. And this need not be drawn when you are drawing the ray diagram. This I just did once to explain, right? So this need not be drawn in the ray diagram. Okay, so the capital alphabets are points and the length is small alphabet. Okay, it has a meaning. See, just write optical center. Labeling all the points should be labeled. Direction is direction. अबे कुछ बनाया? डेट लिखा ना तुमने? डेट लिखा तुमने? आज चैप्टर स्टार्ट किया, डेट तो लिखो. ठीक है, एरो सब जगह डायरेक्शन आएगा, पॉइंट्स आएंगे. मैं एक भी पॉइंट मेंशन नहीं. 5 points. 5 points will have to be mentioned. ठीक है, perfect. एरो चाहिए. Before and after, दोनों जगह. दो लिखो, 4. Direction. Okay. ठीक है, so I think most of you and ray diagram you can't read it, okay? वो draw करके ही करना पड़ेगा, and you will require some practice for it. So do practice, ठीक है? उधर बहुत छोटे-छोटे बनाए तो diagram पूरे से पढ़े ना, it will be easy to label and mark. All right, let's go to the third case. Now, what is the next object position? First was infinity, okay? Now, it's very easy to remember. How many points are there? 1, 2, 3. Only 3 points, right? After infinity, you have to keep the object beyond 2f1. Object will now come near the lens. Beyond 2f1, at 2f1, between 2f1 and f1, at f1, between f1 and O. That's it. So you don't have to memorize. The object is now coming closer. And you will realize that the image will now go away. The image will go away and it will increase in size. Okay, so right now it is point sized, right? Then it will be diminished because object size is still bigger. After that, it will become equal size. Then it will magnify. Then it will get highly magnified. So there is a pattern. So no stress. There is a logic into it. As the object comes closer, the image goes away and the size increases, right? After it has become highly magnified, then the image becomes virtual. All images are real and inverted except the last one, which becomes virtual. Okay, so let's see how the image formation takes place when the next object position is beyond 2f1. The object is beyond 2f1. Okay, so where is the object now? Here. We have named the object as AB. Where is the object kept? Beyond 2f1 and above the principal axis. Where is the object kept? Above the principal axis. This side of the lens, okay, which is facing the object is called front side. This side of the lens is front of the lens. This side is behind, right? Now, how many rays we need to draw the image? Only two. The first ray would be parallel to principal axis, and the second ray would be through the optical center. That's it. All ray diagrams will be made by those two rays. And I know the behavior. If the ray is parallel ray after refraction, what happens to it? Passes through focus. So this nature is known to us. And what happens to optical center? Nothing. It passes undeviated. So this ray passes undeviated. ठीक है? ये ऑप्टिकल सेंटर से नीचे आ गए. ऐसे. Okay, so now this is now label. After completing the ray diagram, now you can label. This is F1, F1, O, F2, and 2F. So where is the image forming now? Okay. Yes, so this is A dash, B dash, B dash. So now the image is forming between F2 and 2F. It has shifted away. Correct? Shifted away from F2. And now what is the size? Now the object and image size are comparable, but still image is diminished. Okay. So now, what is the image position? Image between F2 and 2F. It is real and inverted. And diminished. So I have written the three characteristics of image. First, friction is between F2 and 2F. And the nature is real and inverted. The size is diminished. We have drawn the image for object beyond 2F and for object at 2F. accurate. Same size and the image will be at 2f. Recall your concave mirror. Yes, when the object is at center of curvature, image also will be at center of curvature. And it will be of the same size as object. Audible. So what is the clue here? When the object is at 2f1, image has to be at 2f, right? And it has to be of the same size. So this will be A dash and B dash. This is f2. Good. So you have to be careful. The parallel ray has to pass through f2 and also be below 2f2. Okay. So with some experience, you'll be able to draw it. Okay, so image at 2f2. Size of the image is same as same size as same size as object or same as object size? Same size as object. Is it okay? Or same as object size? Huh? As अरे एक चीज बोल रहे बाबा फाइनल बोल तो ठीक तो लिखा है size is object size. हो सकता है ना तो नहीं तो why I feel related to my time. Exactly क्या होता है वो नहीं होता है. Literary हाँ तो I want literary. Size plus का literature बुझाना आवश्यक है. Same size है. Why this is not correct? This is not correct. Same as object size.
That means that the image
Is
just the size of the object.
yeah, which is what it is. But it is real and inverted. I don't know. Ask who is it? Logo madam. Who is the English teacher? Have you ever learned? He ever taught you? This is logo. Is the English like all the time. Okay, compare them. If I write the title size dot,
I think then
there's no rule, man. You can bend it as per convenience.
but that's why we figure out.
Okay, we'll discuss everything after the break. Take care of this.